All right, here we go, ladies and gents. So we're going to be continuing our discussion of statistics by working on now bivariate data. Now, the goal of today's lesson is going to be lesson 63, scatter plots. We'll be able to create and interpret a scatter plot. What we're also going to be doing is covering what this word bivariate data actually means. But it's not necessarily anything too scary. You guys probably already can guess what the word bivariate data is, especially because we've just done univariate data. Today's fact, while you guys are copying down lesson 63, is 63 is the longest an internet domain name can be. And there are actually a couple of different examples of domain names with 63 letters. So therefore, one such example is the longest domain name in the world, and then some, and then some, and then some more, and more.com. And so if you actually look that up, it is actually a real legitimate domain name with 63 letters. It is actually, and they are actually, from memory, it's like they applied for the Guinness Book of Records, but they couldn't get it because ultimately it was just a name for a website. So when you, it's like one of the rules in the Guinness Book of Records is you can't get a record for just naming something. You know, you can't just be like, hey, I named my son 1, 2, 3, 4, 5, 6, 7. Can I get a Guinness Book of Record for the most numbers in a child's name? It's like, no, you can't just get a Guinness Book of Records for doing something like that. But there are a lot of ways you can get Guinness records and stuff like that with the Guinness Book of Records. So, but yeah, scatter plots. Let's see, we will be able to create and interpret these scatter plots. So we're going to start today's lesson by talking about bivariate data and what that term actually means. So let's jump in right away. I'm going to change the slide now. If I'm going too quickly, again, let me know, guys. So firstly, scatter plots. Bivariate data. Bivariate data is essentially two variable data. And that's because that's exactly what the part of the word means. Bi means two. Variate means just variable. So two variable data. So when we think of two variable data, we usually think of X and Y, but there are many other examples. So when we talk about two variable data, we talk about, well, what two variables could you use? You could use time of day, and you could use temperature. You could use homework and test scores. You could use years of education and average income. You could use a person's height and their birthday month. What bivariate data is? Bivariate data is using one variable to explain changes in another. That's what bivariate data is about. So yeah, that's what the main goal of bivariate data is. Compare this to the topic that we just did on univariate data. You might say, what's the difference between that? So univariate data, what we would have done is we would have just got different values. We would have just got homework. And so what we would have just done is we would have just got a lot of different, 3, 2, 1, 4, and we could have found, like, we could have done a box plot or a histogram, but ultimately we are not able to compare them. We're only able to figure out, well, how much homework or whatever someone is doing. What bivariate data allows us to do is it allows us to say, right, cool, that's great that we have this understanding of this data, but how does this data change with respect to this other data? How does this data explain this data? Is there a link or is there not a link? That's going to be the big part of this topic. Is there a link between this data set and this data set, or is there not a link between this data set and this data set? I'm going to keep this slide up for a little bit longer. We'll go with another 30 seconds, and then I'm going to move on to the next sort of idea. There's, of course, lots of different examples that I could have chosen for bivariate data. And I chose just some of them, just some common examples that I've seen in questions, essentially, as I've been teaching the subject for a while. All right, so let's jump ahead. So this is what bivariate data is. And I'm actually not going to spend, so the main goal is going to be what can we do with this data. So the first thing I would like to talk about is the type of variables. The first is the independent variable. Now, I think I've discussed this already. No, maybe I have. I can't remember, but I get lost because I've discussed this with different groups of people, but I may have explained this already, but if not, let's go through it anyway. I think I may have talked about this in linear equations. Yeah, we did talk about this before. Okay. So we have talked about this before, but I'm going to go over it again anyway. You guys can maybe rewrite it down, recopy it down. If you think we've done this before, you can ignore, and you know it off the top of your head, then you can ignore it. But I'm just going to go through it anyway. The independent variable is known as the exploratory variable. It's the variable that is known. It's the variable that is unaffected. It's the variable that we measure, and it's usually the variable that we control. If you are adding in 1 ml of acid and you're looking at a change, then we are in control of the amount of acid added. So that makes it an independent variable. If you are adding a different mass to a spring, then we are in control of the amount of mass added to the spring. Even time, if you're measuring every hour after sunrise, then we are in control because we are the ones that are looking at the clock. Some common examples, the common examples that I usually see for independent variables are time and length or distance. Now, dependent variables are sometimes known as response variables. That's a variable to change with the changes with a change in x. So as x, so they respond or depend on the independent variable. They respond to the explanation. Some examples, some basic examples of response variables include like something like money or temperature. Now, the explanatory variable is usually an attempt to explain an observation. So many cars on the road, I wonder if there is a way of explaining that. So that's what we're trying to do. So you might say, hey, there are so many cars on the road right now. I wonder if there's a way of explaining that. So you could explain that, you could look at the time of day and use that as a way to explain how many cars, why there are so many cars on the road. Or you might look at, there's so many cars on the road, you might look at the weather and see if the weather explains it. You might look at, there's so many cars on the road, you might look at the month of the year and see if that explains it. There are so many cars on the road, you might look at the amount of leaves on a nearby tree and see if that explains it. Some of these explanations will be really good ways of explaining why there are so many cars on the road. Some of these explanations might be really bad for explaining why there are so many cars on the road. But you know, the weather might not have any effect. It might have lots of an effect. And so response variable is the way one variable responds. This is actually way too much writing. I'm sorry. Don't worry about copying this part here down. You can if you want, but I'm looking at that thinking that's way too much text. Response variable is the way one variable responds to another variable. It is dependent on the variable. By heating this metal to a higher and higher temperature, the metal responds by expanding more and more. So in that case, the response is how that changes. So the metal is responding to the heat. So you could say, well, the metal's expansion is linked to the heat, so on and so forth. So and the last thing that I think I normally do is I normally say the independent variable is going to be x. It's going to be plotted on our x-axis, whereas the dependent variable is going to be plotted on the y-axis. I said, don't copy this part down the bottom. There's too much words here. You can if you want, but I'm not going to keep this slide up long enough for you guys to copy all of it down. I just want you guys to understand the different types of variables. So then when it comes to plotting or looking at things, you guys need to understand the explanatory variables, the thing that's unaffected, thing that we're trying to use to explain what's happening to our y, what's happening to our dependent variable. All right. I really don't like this slide. I think I've done a very bad job of this slide. And I've already shown you this slide anyway, so let's keep going. So now, this is actually a little bit important, but not, this is important, a little bit important, but it's also dependent. Now, when it comes to doing tests and extended response tasks on this topic, I will be asking you guys probably over time to do scatter plots. And this is actually relatively important because this also applies to other areas as well. And I'm going to talk to you guys about how I do this. Essentially, things I check for. Now, usually what I will do is most scatter plots will be worth usually about 4 marks. Sometimes 3, but usually about 4 marks. And so as a teacher, I've spent some time trying to figure out what is the most logical way to award marks for a question. And I usually award marks based on these 4 things. The first thing I do is space. Have you used the space provided? And one of the rules that I usually apply here is the 50% rule. Now, I think I've talked about this to 1 or 2 students, but I don't think I've ever really properly sat down and explained it to you guys. So let me show you what I mean by that. Let's just say we've got a graph. Well, let's just say we've got we'll say we've got making a scatter plot. And we'll go with this. And we'll go with this. Now, let's just say that we have to draw the scatter plot in the axes provided, which would be good. But yeah, what I have seen some students do is they will draw the graph in the axes provided, and it'll look like this. And I'm like, there's actually nothing wrong. Sometimes even worse than that. Sometimes it's actually even more like this. And I'm like, there's nothing wrong with this graph. It's like mathematically. But what you can see here is that we've got all of this empty space. And I will actually take 1 mark off if you do something like this. You want to, when you're doing a graph, try to take up as much space as possible. Because the more space you take up, and yeah, so that's the same graph. I tried to draw the same graph, but I tried to take up more space. The reason for that will usually be based on the scale. So what people will do with the scale is they go, oh, well, there's 10, 20, 30, whereas something like a scale like this might be more like, okay, here's 15, here's, you know, or whatever. Sorry, here's, you know, well, it might be like, here's 10, here's 5, and so on and so forth. So you want to take up as much space as possible. Now, some of you guys might say that's just because they don't want us to waste space. But there are a couple of reasons why it actually makes sense to take up as much space as possible. One, it makes trends more visible to see. It makes it easier to see, oh yeah, there is a trend going on that looks like this. The other reason why it's also good is it makes doing measurements easier, and it finally makes us teachers being able to see the picture a lot easier. So that's what I mean by space. The second one is scale. Does your scale make sense? On the bottom here, I have two scales that make relative sense. I've got 5, 10, and I've got 10, 20, 30. These scales make sense because they work. There are two types of scales that I've seen in the past where students do stuff and I'm like, what are you doing? That doesn't make sense. Let me show you what the two ones that I don't think make sense. The ones that I see that don't make sense are ones that look like this. The first one, and this annoys me, is this one. People that go up by 3s. And I'm like, they go, yeah, it makes sense. And I'm like, you know what? That scale does work. Like, I'm not going to lie. It's one of those ones that's like, yeah, sure, you can correctly do it. But let's just say I've got a value that lands in the scale here. I ask you, well, what is that measurement? You go, well, it's, well, let's say I put a point right here between 3 and 6. And I go, well, what is that measurement? Is it 4.5? Is it 5? Is it 4? It's hard to tell. So when it comes to using scales that make sense, you should stick to the basics. Either 1, 2, 3, 4, etc. Or 2, 4, 6, 8, some kind of multiple. The other one that I love is there are also 5, 10, 15, 20. And then everything else is just multiples of that. So if you go, well, what about 10, 20, 30, 40? That's the first one. You just multiply it by 10. You can also have 20, 40, 60, 80. That's the second one, except it's multiplied by 10. You can also have 50, 100, 150, 200. That's the bottom one, and so on and so forth. Those are the three that I stick to. Don't try and get fancy and use these kind of 3, 6, 9, whatever, or 7, 14, 21. I don't think I've ever seen that, or even 6, 12, 18. Just avoid those, stick to these basic ones. Scale will also help you figure out this top one here. These two are linked because, of course, you need to know how to get a good scale. The best way to get a good scale is to look at your highest value, and go to the round up to the next whole number, and then use that as the top of your scale, and then go down from there. So those two ones are linked. The other way that scales don't make sense, and I've seen this before as well, just let me show you that, is people that do this. And I've seen this before. It looks like this. It sort of goes like, I don't know, we'll go with 10, 20, 30, 40, 50. And I'm like, okay, cool. You're going up by 10s, except here. Here you don't go up by 10s. You go up by 5 and then 5. So then you get 25 in the middle. And so you're like, are you going up by 10s or are you going up by 5s? What are you doing? And you might think, oh my God, sir, do people actually make that mistake? Yes, they do. They change their scale halfway up the graph. It's usually really close to the bottom. They'll be going up by 5s and then they'll realize, oh wow, I'm going to run out of space. I better start going up by 10s, or they'll skip one. It's just like, no. This is why I also suggest that you do your scale first. Don't try to do your scale at the end. Spend some time getting your scale right. Next, labels. Make sure you have labels with units. Meter, like, distance measured in meters. And then temperature measured in degrees Celsius. Make sure you've got units. And then accuracy. And this is probably the one that students spend the most time on, and the one that I spend the least time checking. Did you actually get your points where they're supposed to be? Usually students will get 100% to that, but I will have seen some students that are like, oh yeah, there should be a point at 40, but they completely miss it. So just those are the 4 things that I use when it comes to marking your scatter plots. And a lot of teachers will use other similar things to this to mark scatter plots. It might be a little bit different, but they're the ones that I usually look for. When I've run out of, like, if it's only a 3-mark question, then I won't worry about looking at space. I'll just look at scale, labels, and accuracy, because they're more important than space. But those 2 things are still important. I think space is still important. Are there any questions about this? Wish I had some examples that I could show you, but like of students doing silly things, but I haven't got any with me at the moment. But I've seen some crazy, especially from your class this year, guys. I've seen some crazy scales, like 3, 6, 9, and someone, and then they have 1.5. They actually wrote 1.5 on the scale. And I'm like, what are you doing? Like, try and it's not wrong. It's not like it's like it's annoying for me. It's like, you can use a scale with 3, 6, 9, but it just makes life so much more complicated. And I always I'll usually give a half mark off for something like that, because it'll be like you've at least got a scale. It just is a very odd scale. It's a very nonsensical scale, and it makes reading the graph really challenging. The first thing I'm gonna do now is I'm actually gonna construct a basic scatter plot. Now, I'm gonna make this optional. You can choose to construct the scatter plot with me, or you can choose to not to, but I'm gonna actually take into account these rules here that I've got to try to make sure that how would I do this to make sure that I get the maximum amount of marks. So here what I've got is I've got some days. I've got day 1, a new restaurant is opened up and records the number of customers each day after they open. Use this information to construct a scatter plot. So we've got 1, 2, 3, we've got these days. And then down the bottom, we've got the customers that have come in. So what I'm going to do here is the first thing I'm going to do, which I would normally do, is I look for the highest and lowest number. So I've got a high number here at 24, and I've got a low number here at 4. So that means I'm probably going to want to keep my results. I'm probably going to want to use maybe 25 or even 30 as my maximum value on my graph. So if I was, okay, so let's just say, let's just pretend that I was trying to work this out. Let's say if I was going to make this 30, if I was to go 10, 20, 30, I could fit everything in my graph, but it would mean that I would only be taking up this much space. So that's not going to do. If I go 5, 10, 15, 20, 25, 30, then that takes up a fair bit more space. So that's a good option to go up by 5s. Can I go up by 2s? Can I go up by 2s? 2, 4, 6, 8, 10, 20, 30. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 24. Hey, check it out. I can go up by 2s. I'm lagging. Okay, I got to slow down. My internet seems to be dying. I can go up by 2s. So there are 2 ways that I think I would do this. If I'm lagging, I'm sorry. I'm not much I can do, really. I could go up by 2s, or I could go up by 2.5s. You might say, but so you just said that doesn't make sense. 2.5 does sort of make sense because it's pretty much this scale. It's just you're breaking it up over 2 marks instead of 1. So what would that look like? Let's do that one. Let's do this one because I want to show you what that might look like if it's a bit weird. So what I would do is if I'm going up by 2.5, I'm going to skip the first one and just put a 5 here. Now 2.5 is a legitimate one, you might say, but so you said 3 wasn't legitimate. Again, 5 and 10s are okay. So if I was to do that, then that would be 5. And you could go up by 2.5s. Maybe we won't. Maybe we won't. Maybe we won't. Maybe we'll go up by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Look at that. Perfect. If it was too high, then I would have done going up by 0.5, 2.5s. So that's why I've gone up by 2. So that's how I choose the scale. A lot of students struggle with just choosing a scale. So I would just count. I would just go up like that. There is probably some methods here that allow you to suggest which ones to go up by, but I just try a couple and see which one works. 2.5 would have been good too, but I'm just like, yeah. So then this axis here is my customers. Whereas this one here is my days. Now we've got 10 days, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm not going to mess around with changing that because 10's 10. That'll do. So then all I've got to do is plot. So let's plot these points down really quick. I've got 1 is 24. I've got 2 is 18. 3 is 4. 4 is 5. So it's between the two numbers. 5 is 4. 8 is 5 is 4. 6 is 8. 7 is 16. 8 is 15. 9 is 10. And 10 is 12. And that gives me this kind of box plot here. That's a box plot. That gives me this scatter plot here. And you can see the scatter plot here is a bit out there. What I tried to do is a bit of a odd sort of scatter plot. I wanted to show you guys, I guess, let's just check. Did I take up more than 50% of the page? I did. Does my scale make sense? It does. Do I have labels? Yeah, I got labels. And is it accurate? Well, what I would normally do, and I'll let you in on a secret. I'll let you in on a secret, ladies and gents. You guys might not want to hear this. What I will do is, as a teacher, how I mark accuracy is I just look at one value. I'll go, what's a difficult value? I'll go, you know what, 4, 5. I'm going to look at how the student looked on 4, 5. So I'm going to go across to 4, I'm going to go up to 5. Yep, that'll do. That's in the right spot. Tick for that mark for accuracy. So, and that's how I do it as a teacher. And you might be like, well, because I'm like, if you're going to make, I'm just going to check one value. So even though this value here might have been put in the wrong spot, I might not check that because it's like, I don't have time to check every single, quick, I've got to check every single value. That's going to take a while. We'll check 1 or 2 values and then that'll be it. So hidden hacks, teacher marking tests hack. So that's how we could construct that's how I would construct a scatter plot. Am I still lagging, guys, or is it just for Arm that I'm lagging, or is it for the people at the school that I'm lagging, or are we good now? Because I'm going to move on.
Pretty good, sir.
We're good? Okay.
Yep.
Well, so that's how to construct a scatter plot. Now that's actually the main sections in 7A and 7B. And what I could do is I could give you guys just 7A and 7B to work on now, but I wanted to just quickly talk to you guys about 7C as well. The reason for that is that 7A and B, as I said, are really short. I want to do 7C as well. This 7C should only take me about, about to 15 minutes to do, probably on top of this, and then you guys can have the last 30 minutes to work on. So we'll see how we go. So this is all about how to construct scatter plots. Firstly, I said, well, this is what bivariate data is. I said, this is what the vocabs of independent, dependent variables and what they actually mean. And then I just finished up with how to do a scatter plot. What I'm going to talk about now is I'm going to talk about how to interpret a scatter plot. And interpreting a scatter plot is like the opposite. It's like, okay, cool. Now you know how to create a scatter plot. I want to show you guys how to interpret a scatter plot. And we're just going to focus on the basics here. This should only be done. This should only have 2 slides left to copy down. I think it's this one and then this one. Yep. So there's only 2 slides to copy down now. So let's talk about this. So when interpreting a scatter plot, remember interpreting means when you extract the information from a scatter plot, you when interpreting a scatter plot to see if 2 variables are related, we use 3 measurements. So we use 3 measurements when we're talking about the relationship between 2 variables. The first one is the strength. How close to a line is the graph? What you might see that as is your scatter plot just a random mess of numbers thrown everywhere with no pattern to them whatsoever? Or are these points on your scatter plot or your bivariate data so much in line that it might as well just be a straight line? Like it looks like a straight line, not random points. That's what we're referring to when we refer to strength. Now, I've used the word straight line. I will be careful with that because ultimately it doesn't have to be a straight line to be a strong relationship. You can have a strong relationship or a strong correlation even though it's not a linear line. And I'll explain that in a second. Hold on a sec. I'm just going to quickly do something. I'm back. So the second one there is direction. Now, direction is if the line is either in a positive direction or a negative direction. Is the relationship an increasing direction or a decreasing one? Reminds me of all like, is this a positive feedback or a negative feedback, so on and so forth. And that one can be done by just looking at the gradient. That's pretty much it. The last one here is the shape. If there is a line, is it a linear line or not? Is it linear or non-linear? Now, you guys have done non-linear graphs. You know what they look like. So just like, is it linear or not? Sometimes it's hard to tell. And then underneath that, I've got a phrase. This phrase, there is a strength, direction, shape correlation between X variable and Y variable. Those ones in brackets, just replace them with different words. I'm going to show you what I mean by that in a second, but yeah, that's how you create an interpretation. You say there is a strong, positive, linear correlation, or there is a weak, negative, non-linear correlation between, yeah. So these, and the last thing I've got written down on the slide is you can still get outliers in this data, but they aren't recorded. So you might get a random point that's just flying out in the middle of nowhere, like an outlier, like we're used to in univariate data, but we just don't ignore it. So on this graph here, we've got a graph of a thing which is how tall you are to this idea of how much you weigh. So how would I do this for this graph? Let me show you. You don't have to copy this down, but I'm just going to show you how I would do it. I would say there is a moderate because it's not strong. I'd say it's moderate, maybe, you know, it's pretty strong, but it's not that strong. There is a moderate positive, because you can see this is going up and to the right, so it's positive. And I would actually say this is pretty linear, like it looks like a straightish line. There is a moderate positive linear correlation between the x variable, between how tall, so between height, and this one here, which is weight, between the x variable and the y variable. And that's how I would do it for this one. You don't have to copy that down. I'm just showing you an example of how you would do it. I'm going to change the slide in about, I'll go from a minute from now, and then we'll talk about the last little bits. Yep, I'm definitely going to have this done before, I reckon I'll have this done before 12. So what I wanted to do for this next bit is to go into a little bit more detail with these three terms here. I originally had you to copy them down, but I've actually already got you to copy them down here, so there's not really any need. We're going to talk about the first one, which is strength. Strength refers to how close to a line it is, as I said here. How close to a line is the graph? So we've got here three examples underneath. I wanted to show you. And we're going to spend some more time, we're going to spend some time later on this week doing this. We're going to be spending some time quantifying this idea. When we say strength, is there a number that we can give to it? But at the moment, we're just going to stick to some basic ideas. We've got this idea here, which we call strong positive. So this is what I would say, strong positive. We'd say this is a moderate positive, and we'd say this is a weak positive. So actually looking back at this, I probably shouldn't have said moderate, probably should have said weak, because it's actually not very strong in comparison. But you know, it's also a little bit up to interpretation here. Yeah, I think that's probably a weak positive. But it's hard to call it. I'd say it's very hard. And then obviously this is a little bit up to interpretation. So if it comes down to a test, it's going to be like, you know, because it's up to interpretation, this will probably be more likely to be a multiple choice question, but still, I'm also going to be lenient. If it's very clearly strong, then I'm going to be like, yeah, yo, it's strong. If it's very clearly weak, then I'm going to be like weak. But if you're saying moderate, I'm not going to be like, yeah, no, 0 marks. But that's just what strength means. It's how close to it. So you might think about this as being is your description, is your correlation, does it make sense? Here, this sort of makes sense. It does make sense that the taller you are, the more that you weigh. That does sort of make sense. A weak correlation might be something like, oh, does the weather affect the amount of cars on the road? And you might be like, well, the weather sort of affects the amount of cars on the road, but not really. So that might be a weak correlation, whereas the time of day does affect the amount of cars on the road. So that might be a stronger correlation. So yeah, you'll have to examine that. So that's what strength is. The next one, of course, is direction. Direction is You got positive and negative. That's pretty much it. So negative means it's sloping down. Doesn't mean it's and it's got a negative. So as your one variable goes up, the other variable goes down. That one's relatively simple, in my opinion, to spot. This one can be a little bit challenging, but this one is very much like, oh yeah, I can see which way it's sloping. The last one that we talked about was shape. So on the left here, we've got a strong positive linear. So this one is linear, whereas this one is non-linear. Now I'd still say this is strong and positive because it's still very close to a line. And it's also still going up and to the right, but it just isn't going, it's curving up, not going straight up. So therefore that makes me think that it's non-linear. Other non-linear shapes might look like this or like this, whatever. You'll be able to tell if it's non-linear. So those are the three conditions, but the one extra one that I wanted to throw here is no correlation. It is entirely possible that you will get no correlation. Then you would just say there is no correlation between the X and the Y. And because there's no correlation, you can't say that's the strength. There is zero strength. There is no correlation. The strength, there's also not a negative association or positive because you can't tell because there's no correlation. And again, you can't look at the shape because there is no correlation. There's no shape to be made out here. So just be aware of things. There can be no association. That can be completely, that's a completely valid suggestion. The last thing that I was going to get you guys to look at was this picture here. So this is just a quick one that I've pulled out. It looks, you might think it looks similar, that's because it is. We've got here income and years spent studying. So what we're going to do, you don't have to copy this down because you've already copied this down already, but we're going to do another example of that. So you might want to copy the example down this time because if you didn't copy it down last time. So I'm going to say there is a, now that's pretty close to a line. So I'm going to say strong. The direction is sloping up and to the right. So we say positive. There is a strong positive. Now this is not linear. You can see here a linear line would be like that. But this is sloping upwards. So there is a strong positive, non-linear correlation. Now correlation just means relationship, by the way, between X variable. What's the X variable? Years spent studying. Between years spent studying and Y variable. What's the Y variable? Income. And income. And that's how I generate an interpretation of a scatter plot. Now, the reason that I'm showing you guys this is because I want to give you guys and you guys will have to cover this later on when we do other similar things. I want to give you guys like a fill in the blanks thing. So the second you see something that says interpret this scatter plot, you can be like, here is a fill in the blanks that I can just write. Because I know for some of you guys that might struggle with the English, you might struggle with English, this might be a good one. Now, for those of you guys that are doing literature or doing, really well in English, do you need to follow this script? The answer is no. You will not be marked down if you don't follow this script. If you say the relationship between the years spent studying and the income achieved is a strong linear one, a strong non-linear relationship, which is sloping in a positive direction. That's completely fine. You can, there are so many ways that you can summarize or interpret this graph. I'm just giving you guys a cookie cutter sheet. And there is going to be another section here where it's going to be interpret the gradient, which is going to be very similar to what we did in, we're going to be interpreting the gradient and interpreting the y-intercept, which is going to be similar to what we did in linear graphs. And I'm going to give you guys, again, cookie sort of cutter, sort of basic fill in the blanks statements that you can use. You don't have to use the fill in the blanks, but you can. Does that make sense? All right, so that's all that I wanted to cover with you guys today. I have just got to 12 o'clock. I'm hoping the 2 students that are doing the test have finished that off now. I'm going to close that in a second anyway, but let's go have a look here. So those are the 2 major things we covered. First one being what is the bivariate data? How do I construct a scatter plot? And the second one is how do you interpret them? So what I'm going to give you guys the rest of this lesson to work